To understand the principle of strobe dynamics, we must first understand what it is not. For the past century, incredible machines have dominated the skies, adhering to a principle of flight first proposed in antiquity by forward-thinking men of natural philosophy who observed the motions of birds and insects, then translated those observations into rudimentary designs that took to the skies, if only in theory. The practice of mechanized flight, which was realized as a practical system in the 20th century, evolved quickly into a global transportation phenomenon which today utilizes the age-old principle known as aerodynamics. Aerodynamics is a science of airflow over and around objects. Aerodynamic principles are used to determine lift, drag, maneuverability, and stability through calculated design of wings, body surfaces, propulsion systems, materials, and numerous other aspects. Flight characteristics may vary with altitude, atmospheric temperature and pressure, wind velocity, and a host of other external factors. Airflow is governed by the principles of fluid dynamics. The viscosity, density, compressibility, and temperature affect how air will flow around an object. Viscosity is a fluid's resistance to flow. Although air is less viscous than water, viscosity is an important factor against a solid surface because gases, like liquids, apply friction to a surface, reducing that flow. Drag is the force created by a vehicle traveling through the air that opposes the motion of that vehicle by introducing friction and pressure differentials against and around the vehicle's surfaces. Lift is the upward force that keeps an aircraft acting against the force of gravity. In general, conventional motor-driven aircraft must travel fast enough to generate the opposing pressure required to offset gravity or, in the case of helicopters, hovercraft, and jump jets, must produce enough downward force to negate their own weight. The principle of aerodynamics is entirely dependent on the presence and characteristics of atmosphere, the collection of gases and pressures that make up what we call air. Without this crucial element, the principles of aerodynamics are completely void. The theory of strobe dynamics attempts to explain several commonly reported flight characteristics of observations labeled unidentified aerial phenomena, or UAP. The actual mechanics of bending or warping space-time may be undisclosed, but the idea that the fabric of space and time are intrinsically linked and can be altered, if not manipulated, was theorized by Albert Einstein and observed in the path alteration of light traveling close to a star. In these observations, the gravitational field created by the mass of the star bends the surrounding space and in turn alters the course of the light passing near. This concept opened the door for physicist Ludwig Flamm to theorize the existence of white holes, considered the antithesis of black holes, which, when connected by a space-time conduit, could allow for circumventing the limitations of light speed by creating what is commonly termed a wormhole to move an object between 2 points, yet bypass observable space in between. Although this exercise addresses only hypothetical vehicles traversing within the Earth's atmosphere and well below the speed of light, the principle of manipulating space-time is assumed, much as a contemporary of Leonardo da Vinci might have contemplated the principles of aerodynamics centuries before the advent of the combustion engine. Considering these precepts, it will be assumed also that the engines capable of manipulating space-time are a possibility if distant, or if only with an understanding of physical forces yet unknown to the public. Unidentified aerial phenomena is a label given to alleged sightings of assumed vehicles which appear to exhibit flight characteristics that go beyond the capabilities of known aircraft that adhere to the principles of aerodynamics. These reports tend to have a few common observations. It has been reported that UAP travel at speeds greatly in excess of known but not necessarily conventional aircraft operating beyond the stress tolerances of known materials and design. That UAP can immediately increase or decrease velocity without accelerating or decelerating, or the gradual ramping up and down of speed. Also, beyond the capabilities of common aircraft, and that these unusual vehicles can make immediate alterations in trajectory without decelerating, banking, or following a radial path. Again, operating beyond the stress capabilities of known materials and design.
T-minus 10, 9, 8, 7, 6, 5.
G-force, or gravitational force, is a force acting on a body as a result of gravity, acceleration, or centrifugal motion, informally described in units of acceleration equal to 1g. All known matter is subject to the principles of G-force. In particular, known aircraft and their occupants can be subject to near intolerable levels of G-force when exercising high-speed, high-angle maneuvers. According to spaceanswers.com,
high levels of G-force can damage the body, and at around 9 Gs most humans black out as blood struggles to reach the brain. Astronauts normally experience a maximum G-force of around 3 Gs during a rocket launch. This is equivalent to 3 times the force of gravity humans are normally exposed to when on Earth, but is survivable for the passengers. Astronauts are trained in high G-force, wear G-suits, and must be correctly prepared.
Paraphrased from an article from Aviation Online magazine,
in a constant altitude, coordinated turn in any airplane, the load factor is the result of two forces: centrifugal force and gravity. For any given bank angle, the rate of turn varies with the airspeed. The higher the speed, the slower the rate of turn. This compensates for added centrifugal force, allowing the load factor to remain the same. Load factor increases at a terrific rate after a bank has reached 45 or 50 degrees. The load factor for any airplane in a 60-degree bank is 2 Gs. The load factor in an 80-degree bank is 5.76 Gs. The wing must produce lift equal to these load factors if altitude is to be maintained. For a coordinated, constant altitude turn, the approximate maximum bank for the average general aviation airplane is 60 degrees. An additional 10-degree bank will increase the load factor by approximately 1 G.
propulsion is the action of driving or pushing. All commonly known vehicles utilize some system of propulsion, most common being some type of combustion or electrical engine whereas thrust is generated, expelling a force which propels the vehicle in the opposite direction. Yet this system of movement is subject to physical laws that add stress to materials and biology. Changing direction or changing velocity exerts stress. A body in motion stays in motion until the course is altered by stress-inducing factors that act upon the current kinetic energy of the vehicle. Stress can be limited by increasing the time it takes to make the change, accelerate slowly or turn gradually. Sudden change increases the stress applied. Immediate change is impossible, yet often perceived, such as a rubber ball bouncing off a brick wall. However, the ball does not immediately change direction, it compresses then decompresses, absorbing then redirecting force before changing direction. Considering the reported characteristics of UAP, the stress is imposed on common aircraft constructed with known materials and utilizing a conventional system of propulsion would most likely be catastrophic. In order for the unconventional flight characteristics of UAP to be achievable, the notion of propulsion by means of expelling force in one direction to cause movement in the opposite must be dismissed. This is due to the proposition that UAP do not utilize propulsion by conventional definition. They do not drive or push toward a location by expelling thrust in one direction to push the vehicle in the other. They do not fly from point A to point B. Their position in observable space is altered incrementally, in rapid successive bursts, many times per second, in and out of space-time, without the effects associated with common propulsion. Strobe Dynamics suggests that the vehicle is enveloped in a gravatic field which allows it to disappear and reappear, fluctuating into and out of space-time at a controlled frequency, appearing either in the same relative position, seeming to an observer to hover, or appearing at a new position of a relatively short distance, probably within the generated field, but at many times per second, with the alteration of position being incrementally further from its starting point, as with waypoints on a map. By disappearing from one point and appearing at a successive point at a rapid, controlled rate, an external observer would perceive the vehicle as flying through the atmosphere, yet the vehicle and occupants would experience no G-forces. To an external observer, the UAP may appear to defy the laws of physics by making immediate changes in trajectory, even 180 degrees, at speeds that would be impossible for conventional aircraft. It would appear also to make immediate changes in velocity without acceleration or deceleration. It would appear to execute maneuvers that would be catastrophic to conventional aircraft and occupants, yet to the occupants, if any, the vehicle would not feel to be moving at all. To the occupants, the experience would be akin to watching a movie of a dash-cam roller coaster ride on the big screen. Occupants could see the geography moving at all angles and speeds, yet would not be affected by the forces normally associated with that movement. Traveling from one location to another by means of bending space-time may be analogous to pouring liquid into a funnel. Everything within the field is stretched to the next location, including light, to emerge at the other end in its original form. By this method, it may be reasoned that an object can only travel a distance that its matter can be stretched. However, greater distances could be achieved by a repetition of this process. As for the distance that an object may be stretched, consider the following speculative excerpt from Ask a Mathematician Physicist.
Taking their size in terms of bond length, and looking at the most common elements in the human body, by mass, 67% oxygen, 18% carbon, and 10% hydrogen, you'll find that 1 kilogram of person will stretch about 7 trillion kilometers. So an average 80-kilogram human would extend about 550 trillion kilometers, or about 14 billion loops around the equator, or 1.4 billion trips to the moon, or about 58 light years.
From within, and during the in or visible phase, gravity always acts as if the craft is hovering in place, regardless of the craft's apparent motions or speed through observable space. Gravitational pull of a celestial body like Earth is always applicable to the vehicle, occupants, and objects within, given the distance of the gravitational source. As with any object, the closer to the source, the greater the force of gravity. The gravitational effect is the same when appearing to hover, as when the craft is moving at high speeds. Although it may be possible for the vehicle to simply jump from one location to the final extent of a path, as opposed to traveling in succession along that path, further speculation may suggest that traveling in short successive bursts may better allow for acute observation of a given area, allowing synchronized instruments to operate without obstruction. This might explain why UAP are generally observed for only short periods and have been reported to simply disappear. A vehicle that exercises strobe dynamics, regardless of the speed it appears to an external observer to be traveling, does not possess momentum. It does not move through visible space by conventional kinetics, but emerges, however rapidly, in incrementally distant static positions, traversing forward in observable space. If disabled, it would fall directly toward the source of gravity as if it had been hovering, regardless of how fast it was observed to be moving prior to power loss. In essence, the observable motion of the UAP itself is similar to a film strip. A film strip consists of individual frames. Each frame is an image which changes incrementally from one frame to the next, producing the illusion of motion. The vehicle's motion through a given space, within a single dimension, is also an illusion of this nature. To an external observer, the vehicle is traveling continuously through the atmosphere from point A to point B. Yet this effect is similar to the frames of a film being projected sequentially and in rapid succession, indiscernible from actual motion if performed at a high enough rate to deceive the eye. This exercise does not attempt to prove or disprove the validity of UAP reports or speculate as to the origins of such craft. This exercise does not suggest that strobe dynamics is utilized by any existing craft, regardless of origin, yet merely proposes a system to match reported flight characteristics of these unusual sightings. Given the limitless nature of engineering, it is probable that alternate systems of motion exist which may exhibit the same unusual flight characteristics as seen by an external observer.